Welcome back everyone. This is the third lesson recording for IM1, February 5th, 2021. So let's summarize the PADAC activities. So possible strategies for solving equations that you should be confident in at this point is apply undo operations on both sides of equal sign. So when you have this kind of equation, 3x minus 11 is equal to 40, you need to first get rid of this negative 11 because that was the last thing that was done to x. X was first multiplied by 3 and then subtract 11. So you need to undo negative 11 by adding 11 to both sides, and you are left with 3x is equal to 51. And what about distribution? If you have expressions with parentheses, again, the reason you do distribute is because you cannot simplify what's inside. So the only way you can get rid of parentheses when a number or something is being multiplied to a parenthesis is by distributing 3 to 2x and 3 to 5 by multiplication and then adding them together. So 3 times 2x is 6x and 3 times 5 is 15. So 6x plus 15 is here, and then plus 2x from here, and then also combining like terms on the same side of equal sign. When you see this, okay, so what are the like terms that we can combine? I see that 6x and 2x are like terms here. What about this example? Okay, 4x plus 12 plus 2x is equal to 3x. Problems like that, again, you should be looking at one side of the equal sign. I see the 4x and 2x are like terms, so I can combine those, and that becomes 6x plus 12 on the left hand side and is equal to 3x. The right hand side has not been touched, so it stays as it is. Okay, so solving systems of equations, we learned 3 different methods. So at this point you are going to be taking notes, so make sure you have your notebook, and you will be turning this in at the end of the class. So take good notes, please. Alright, so equal value method. What does that mean? Remember our burger, juicy burger and french fries was the price of juicy burger is equal to french fries plus 18. And I was also told you that price of juicy burger is same as price of 3 french fries. Then since we're talking about the juicy burger being the same thing, okay, we're talking about this being equal to juicy burger, but this is also equal to juicy burger. That means we're talking about the juicy burger. They are equal to same thing, so we can combine those 2 equations together and say that fries plus 18 is equal to 3 fries. And then from there we can solve. So that is the equal value method. Okay, so you're taking notes here. This is a new example than the one that you had before. So I would like you to take notes here. Equal value method is used when both equations have the same variable isolated. Here the variable y is isolated. That means it's all by itself. Y is equal to. And again, y is equal to. It's the same variable. If it was y is equal to and x is equal to, that would not work. But when it's y is equal to and y is equal to, that would work. Or x is equal to, x is equal to, that would also work. Then you equate both y values to make one equation because the 2 y's are really the same thing. That means these two, the things that are equal to y has to be also equal to each other. So 7x minus 2 is equal to 2x plus 13. And then from here on, then you are just solving like what we did with the PADAC activity. Okay, we have variables on both sides. We do not want that. So we just want the variable on one side. You have a choice to get rid of 7x here or 2x here. I always like to take away a smaller number, so I'm going to take away 2x from the left hand side and 2x from the right hand side. That will leave me with 5x. Negative 2 hasn't been touched, so it's 5x minus 2 is equal to, on the left hand side, 2x minus 2x, they cancel out to 0. Becomes 0 plus 13, so I'm not even going to bother by writing 0 here. I'm just writing 13 from the number that hasn't been touched. Now I see numbers on both sides. Again, remember, we want variables on one side and number on the other side. I don't want numbers on both sides. I do want number on that side because I have variable on the left hand side. So I get rid of this -2 by adding 2 to both sides. That leaves me with 5x is equal to 15. And then from there, since 5 is being multiplied to x, I undo 5 by dividing by 5 to both sides, and that leaves me with x is equal to 3. Now that I've found x to be 3, I'm not done. I need to find the value for y. I do that by choosing either of the equation, okay, because they're both isolated for y. I'm choosing the top one, 7x minus 2, and wherever I see an x, I am going to substitute or use the value that I just found, which is 3. So 7 times 3 is equal to 21, minus 2 is 19. So then you write the solution together as x is equal to 3 and y is equal to 19, and the problem has been solved. Okay, so what about this? Let's try to solve this problem. Okay, can you try to do it yourself? And I am going to share with you my method in a minute, so pause the video and try to do it yourself. So what do? Well, I know that 6x minus 11 is equal to y, but I also know that 4x minus 7 is also equal to y. Since y and y are the same, then I know that these two must also be the same. So I am going to start by equating those two expressions that are equal to each other. Okay, now I have two variables, the x's and x's on both sides of the equation. Equal sign, I do not want that. Okay, so I need to get rid of one or the other. I can subtract 6x from both sides, or I can subtract 4x from both sides to get rid of this. I am going to subtract 4x from both sides because it's easier to subtract a smaller one. Then you'll end up with a positive. Okay, so then this becomes 0. So you're just left with -7 on the right hand side of the equal sign. On the left hand side of the equal sign, 6x minus 4x is just 2x. And then I have my -11 that hasn't been touched. Now I have numbers on both sides. Okay, which is the number that we don't want? We want the variable on one side and a number on the other side. So we have the variable on this side. That means out of these two numbers, I don't want this number. How do I get rid of this -11? Okay, you can add positive 11 to both sides, because what is 11 doing to 2x? It's subtracting to 11. So undoing subtraction is addition. So then you're left with 2x is equal to -7 plus 11. That's going to be positive 4. Then from here, I know that 2 is being multiplied to x. So how do I undo multiplying by 2? I divide both sides by 2, and you're left with x is equal to 4 divided by 2 is 2. Okay, now that I've figured out what x is, I need to find out what y is. I can choose either one of the equation. Y, I'm going to choose the top one. Instead of writing x, I'm going to put a parenthesis. It's as a placeholder. And then -11. That's my original equation. With this should be filled in with my x value, and my x value I just found to be 2, so I put my 2 there. Then I continue with this 6. The parenthesis 2 means 6 times 2, right? 6 times 2 is 12, minus 11 is positive 1. So I've just found y to be 1. So x is 1. X is equal to 2 and y is equal to 1, or you could represent this as 2, 1 with parentheses on either side. That means this communicates the first number in the parentheses is the x value. This communicates the second number in the parentheses is the y value. So this is a way to communicate your answer. Okay, then let's move on to substitution method. Remember our triangles and circles that we covered last lesson? If we know that triangle has the same value as 3 circles, and we are also told that circle plus value of two triangles is equal to 14. How can we solve this? Well, I know that there is a circle here, so I'm just going to bring that down as a circle. But every time I see I am adding a triangle, I am going to add 3 circles, because each of the triangle I am told is equivalent or equal to. That's what the equal sign is telling you. They have the same value as 3 circles. So I am substituting for the triangle to be 3 circles. That's where the word name substitution method comes from. And again, for another triangle, I'm putting 3 circles, and then on the right hand side, and the equal sign comes down. Alright, so I have 7 circles is equal to, then I have 7 circles is equal to 14. Then that way I can figure out what each of the circle is. That's what the substitution method is. So let's go through this problem. Y is equal to 2x minus 8 and 3x minus 3y is equal to 21. We're going to use substitution method. Why? Because it's used when one equation has the variable isolated. It does not matter whether it's x or y, but one of them is isolated in terms of the other variable. Okay, the y does not occur in both sides, but it just occurs in one side. Then y is equal to 2x minus 8. That means y has the same value as 2x minus 8. So every time I see a y, I can think of it as 2x minus 8 instead. So you substitute the isolated variable into the second equation, and that is the 2x minus 8. Every time I see a y, I am going to replace it with 2x minus 8. So that's my second equation, but with the y being replaced or substituted. Then from here, I know that 3y means 3 multiplied by y, right? 3 is multiplied by y, so I put a dot there just to make sure that I remember that negative 3 is multiplied to what's in the parentheses. At this point, you should only have one variable now. That's something that you need to make a note of. Okay, if you do not, then you're doing something wrong. You cannot use the substitution method, or there are some additional steps involved. Then you solve for the variable. You need to distribute by multiplying negative 3 to each of the term inside each of the numbers and variables inside. So negative 3 times 2x is negative 6x. Negative 3 times negative 8 is actually 24. That's a mistake. Okay, so plus 24 is equal to 21. So then 3x minus 6x, combining like term, should leave me with 3x, and this should be 24 is equal to 21. Subtracting 24 from both sides should leave me with 3x is negative 3. So divide both sides by x, 3, then you should get x to be negative 1. Then from here, again, I'm sorry, it's a typo. This should be negative 1 here. So it should be 2 times negative 1 minus 8. 2 times negative 1 is negative 2 minus 8 should be negative 10. So the correct solution is x is equal to negative 1 and y is equal to negative 10. I will correct this later on. Okay, so at this point, I want you to pause the video and try to solve this problem yourself. I'm running out of time, so I'm going to go through this really quickly. So I write the second equation, but I know that y is isolated, so whenever I see a y, I am going to replace it with what y is equal in value to, that is 2x minus 12. And the rest of the equation is the same. Then from here, I need to distribute each of the 3 to each of the terms inside. So 3 times 2x is 6x, 3 times negative 12 is negative 36, and the rest of the equation stays the same. Then combine the like terms. That's 14x minus 36 is equal to 20. And then from there, I'm going to add 36 to both sides. And that leaves me with 14x is equal to 56. Then divide both sides by 14. And that leaves me with x is equal to 4. Okay, then I substitute that to find my y value. And I did that, and so my y value is -4. So x is 4, y is -4. My table